Hi, PerspectiveWeather.com meteorologist Paul Dorian here on Thursday, June 18th. We're going to focus in on the tropical activity in the Atlantic Basin, and more specifically, the lack of tropical activity right now in the Atlantic Basin. And there's been a major outbreak of dust that has originated in the Sahara Desert region of northern Africa, is now traveling westward over the tropical Atlantic and will actually make it all the way west into the south central part of the U.S. by the early to middle part of next week. This type of dusty, dry air mass has unique characteristics that inhibit tropical storm activity in the Atlantic Basin, and we'll detail all of that over the next several minutes. This happens to be a forecast loop, a 10-day forecast loop from NASA's GEOS, G-E-O-S, atmospheric model. It's a global atmospheric model. That's a high-resolution model, and what we're looking at are forecasts going from June 17th all the way out to June 27th of aerosol optical thickness. In other words, it's a good way to look at the dust in the atmosphere, and again, this dust is not all that unusual for this time of the year. The layer of dust is often referred to as a Saharan Air Layer, or SAL, and it tends to have a season from, let's say, mid-June all the way into mid-August. Kind of tends to peak during the middle part of August, and can have a big impact on the tropical activity in the Atlantic Basin. You can see here the beginning of this time frame, again around the 17th of June, dusty air pushed off the west coast of Africa. Again, it originated over the Sahara Desert region of northern Africa, moves along in the trade winds from the east to the west, and in this case it's going all the way through the Caribbean Sea into the Gulf of Mexico and the southern part of the U.S. by the early to middle part of next week. Now, so far this year, the Atlantic Basin tropical season has been quite active. Officially, the tropical season gets underway on June 1st, but unofficially, it can happen anytime where we have some tropical activity. In fact, we had two named systems during the month of May, and it's about the fifth year in a row where we actually have had a named system prior to the official start on June 1st. In this case, we had a tropical storm Arthur, and this is the storm track that Arthur took, followed by Bertha, both during the month of May, and most recently we had Cristobal, which reached tropical storm status. It kind of looped around Yucatan Peninsula region of Mexico and then went due north across Louisiana and all the way up into the Great Lakes and southern part of Canada. Certainly is somewhat unusual to have three named systems this early in the tropical season. In fact, we haven't had that in about 8 years, since the 2012 season. It's also unusual to see a June storm move all the way north and west to the Great Lakes region. That is quite unusual any time of the summer, but especially during the month of June. However, since Cristobal, there's been a lull in the activity, and a good part of the reason has to do with that dusty, dry, warm air mass that pushed westward from Africa into the tropical part of the Atlantic Ocean, and again, it will make it all the way into the south central U.S. by the early or middle part of next week. Well, let's talk about the unique characteristics of a dusty air mass that originates in the Sahara Desert region of Africa and absolutely can inhibit tropical activity in the Atlantic Basin for a period of time. Again, the SAL, or the Saharan Air Layer season, it generally runs from mid-June, peaks in mid-August, and any one of these outbreaks can reduce or totally eliminate tropical activity in the Atlantic Basin for a period of time, and it can really have an impact over the long term during a tropical season. These are some of the characteristics that cause a reduction or maybe a total elimination of tropical activity. You have to do with the fact that this is very dry air, often very warm air aloft, and it's often associated with strong winds. First of all, in terms of the dryness of the dusty desert air, typically 50% less moisture in an air mass that originates over the Sahara Desert as compared with the typical tropical atmosphere this time of the year over the Atlantic Ocean. And it is generally elevated above the surface, maybe resides in that layer between 500 millibars, 850 millibars, or about 1,500 meters to about 5,000 meters aloft. And drier air is more dense than moist air. It's kind of intuitive to a lot of people to think that moist air is actually less dense than dry air, but indeed it is. So the drier air is heavier air. It helps to produce downdrafts in the atmosphere. Downdrafts tends to be a stabilizing effect, and that's the reason why these dry, dusty air masses, one of the reasons why these dry, dusty air masses tend to reduce or totally eliminate tropical activity. In addition, we have strong winds usually associated with the SAL, or the Saharan Air Layer, maybe as high as 25 to 55 miles per hour. And what this does is it increases the vertical wind shear, tends to help to tilt a tropical cyclone vortex, and that kind of reduces the efficiency of the internal heat engine. In other words, it's an inhibiting factor, just as the dryness of the air was as well. Anytime you have strong winds or increase of vertical wind shear, it tends to reduce activity in the Atlantic basin. Finally, this air that originates over the Sahara Desert can be very, very warm. And once that pushes over the relatively cooler waters of the Atlantic Ocean, kind of acts as a temperature inversion, with warmer air aloft and the cooler marine air closer to the surface of the ocean. That temperature inversion, where temperatures rise with altitude, is a stabilizing effect on the atmosphere. So again, three unique characteristics to a Sahara dusty, dry air mass. First of all, the dryness, the increase in winds, and the warmth, all inhibiting factors to tropical activity. Well, as we said at the onset, we've had an active season so far in the tropical Atlantic with three named systems, Arthur, Bertha, and Cristobal. This early in the season hasn't happened for several years. However, because of this onslaught of the dusty air mass over the breeding ground regions of the Atlantic Ocean, a forecast map from today from the National Hurricane Center, which is based in Miami, no activities expected over the next 5 days, and it seems like a very believable forecast here, given the extent of this outbreak of dusty air that is quite significant, and again, it will penetrate all the way west into the south central U.S. by the early or middle part of next week. Well, one final point I'd like to make as we wrap up here is that with the introduction of dust into the atmosphere, especially the middle layers of the atmosphere across the southern U.S. over the next few days, especially by the early and middle part of next week, you can have orange and reddish sunsets because of all the extra scattering that will take place in a dusty atmosphere. So this is a photograph of a very orange looking sunset over the Gulf Coast region, and that's the specific area to look for these very colorful sunsets and sunrises during the first half of next week, with this introduction of the dust that again will travel all the way from Africa, across the Atlantic Ocean, and reach the south central part of the U.S. It can sometimes travel even far southwest as Central America, but in this case it looks like the dust will move over the Caribbean Sea, over the Gulf of Mexico, into places like Texas and Florida and the rest of the Gulf region. It could even spread out from there depending on the weather pattern that sets up during the early and middle part of next week. It could go farther north than just the southern part of the U.S. So we have a major outbreak of dusty air that is traveling across the tropical Atlantic right now, and it'll reach all the way into the south central part of the U.S., and it is an inhibiting factor to tropical activity in the Atlantic Basin. That's it for now. For PerspectiveWeather.com, I'm meteorologist Paul Dorian.